All right, so let's go through an example of using a hypothesis test for a mean. So in 2010, the mean years of experience among a nursing staff was 16.3 years. A survey of a random sample of 35 nurses at the hospital found a sample mean of 18.37 years with a standard deviation of 11.12 years. Do we have evidence that the mean experience has among the nursing staff at the hospital has increased? Right? Use a significance level of 5%. So we're going to start by listing everything that we know. So our population is all nurses, right? At this particular hospital. Our sample size, 35 nurses sampled. Right. Our mu-naught is the mean from 2010. The mean of all of the nursing staff was 16.3 years. We're told to use a significance level of 5%. We have our X bar, which is our 18.37 years. That was from our sample. We have a standard deviation of 11.12 years from our sample. And then our degrees of freedom, again, we subtract 1 from our sample size. Lost my equal sign there. 35 minus 1 is going to give us 34. What do we want to know? We are asked, do we have evidence that the mean years of experience among the nursing staff of the hospital has increased? Right? So has the mean increased? Right? Increase, we're thinking a greater than symbol. So we're going to start by stating our hypotheses. Again, we're using mu's instead of p's. Mu equals, again, it's very important that we pick our mu-naught value for our mean here. So 16.3, and then has it increased is mu greater than 16.3. Our conditions, our sample is random and independent. Yes, we will assume so. A large enough sample. Well, 35 is greater than or equal to 25, so we are good. Again, we don't have to worry about checking our large enough population, so we're just really looking at our sample size here. Right, so we're going to use StatCrunch. In StatCrunch, remember that we are going into our T-stats, right? One population with summary. We are going to enter our X bar, our S, and our N. So going up here, and we're entering our N, our X bar, and our S. We do want to make sure that when we are selecting hypothesis tests that we get all the rest of the information in there. So we do want to be sure to select the greater than or equal to, and then put our mu-naught value of 16.3 from our hypotheses in there. Once we hit compute, we are given our values. So our value for our T statistic, again, instead of a Z statistic, is 1.10. Our p-value, 0.1398. And then remember, to make our decision, we are comparing that to alpha. So 0.1398 is greater than our significance level of 5%. So our p-value is greater than alpha, and that is going to tell us then to not reject our null hypothesis. Right, so we do not reject our null hypothesis. So if we go up to our pair of hypotheses, we don't reject our null hypothesis. So we're going to circle that guy, cross off the other one. And our question, we were originally asked, do we have evidence that the mean years has increased? We are going to say no. We do not have evidence that the mean experience among the nursing staff has increased. So again, slightly different details than we saw in chapter 8, but our process is still pretty much the same. Right? We start with listing the things that we know, we state our pair of hypotheses, we check our conditions, we enter the appropriate values into StatCrunch. Once we have our t-value and our t-statistic and our p-value, then we make our decision about our null hypothesis, and then we interpret that final decision to finish this off.